Gravity. It is something we all have experienced. But is it real or just another illusion? The quest of humanity to solve mysteries of gravity started with Newton. According to Newton, gravity is a force of attraction between bodies that have mass. But even Newton didn't know the cause of gravity. But then Einstein came with his theory of relativity, and that changed everything. According to Einstein, there are not three but four dimensions: three dimensions of space and one that of time, which he collectively called space-time. You can imagine space-time as a stage on which every event of the universe occurs. So, what can this space-time tell us about gravity? According to Einstein, objects that has mass curve this space-time around them and form a gravity well, which attract other objects that have mass towards itself. Now, why this attraction, you may ask? Because as John Wheeler has said, space-time tells matter how to move and matter tells space-time how to curve. So, gravity is just a consequence of curvature of space-time. But what if I tell you that gravity doesn't even exist? Let me show you. Imagine Einstein in intergalactic medium moving with a constant velocity of 50 meters per second. Frame of reference of Einstein in this situation is inertial because he is moving with zero acceleration and no gravitational force is acting on him. And when something or someone are in inertial frame of reference, they feel weightless. Now, during his journey through space, he came across a huge planet. Newton, sitting under an apple tree, observes that Einstein's velocity starts increasing and he starts to move toward the planet, and then Newton realized that the planet was attracting Einstein towards itself, gravity. But Einstein would still feel weightless, and that means he is moving in a straight line with constant velocity. But Newton saw the planet attracting Einstein towards itself. So how can Einstein move in straight line with zero acceleration? Let me show you. As you can see, this line on this paper is straight. But what can you say about it now? Or now? Does it still appear straight? The line appeared curved because the surface on which it is made is not flat. That is, straight line appear curved on curved surfaces. The same is true for Einstein. He is moving in a straight line, but as the space-time around him is curved, so it appears that he is moving in curved path towards the planet. In reality, Einstein moved through space-time unaffected, but as the space-time around him was curved, so it appears that the planet was attracting him towards itself, and that is what we call gravity.